Okay, today we're going to do notes number 3. So just reviewing, we did function. Is it a function? Notes 1. Notes number 2 was function notation. So today we're going to do notes number 3, which is function notation in context. So this is where we're going to use function notation to solve word problems. So let's kind of review function notation. It says, the first one says, evaluate the function f of x equals 2 to the x minus 5 at x equals 2. If you remember, this 2 for this f means that's what we plug in for x. This x is an exponent, so you're going to have 2 to the second minus 5. 2 to the second is 4. 4 minus 5 is negative 1. You could also type that into your calculator and get the same answer. Next, we have to evaluate the function 3x minus 5 for each of the following. So this one we have 3 different ones. We have x equals negative 3, so we're going to plug in negative 3 for x. So the only thing that's changing each time is this x value. So this is going to give us negative 14. You can put that in your calculator. This one we're going to plug in 7. Hold on, no, this is where, so if it says f of x equals 7, that does not mean x equals 7. That does not mean f of 7 or your x. This means that f of x equals 7, so we're going to plug in 7 for f of x, and we're going to solve for x. This is a little bit different. So this is where we have to do our order of operations, or inverse operations. So we get 12 equals 3x, and then divide by 3. So you would get x equals 4. So these are a little bit different because this is what we're kind of going to be doing today. Now this one, you have f of x equals 25. So we're going to do the same thing as we did with b. So we're going to have 25 equals 3x minus 5. Add 5 to both sides. You get 30 equals 3x. Divide by 3. You get x equals 10. So kind of remember this from our first unit of solving equations. So to kind of recap this, if it says f of 3 or x equals 3, you plug in for x. If you have like f of x equals 3, you plug in for the y or the f of x value, depending on which one it is. Okay, so let me know if you guys have any questions. That is a little bit different than what we were doing yesterday. Next one says there are 5 people inside a park as it opens for the day, and the number of people is increasing by 3 every hour. The number of people in the park can be described as the function p of x equals 3x plus 5, where px is the number of people. So this is where our number of people is. After x number of hours. So x is our number of hours. So that's going to be important to know. Define your variables. So I'm not too concerned about you defining your variables, but we do want to do it. So if it says x is number of hours, x equals number of hours. And y, or p of x, because remember it's the same, is your number of people. So we kind of already defined them. We're just writing them out. So how many people are in the park after 5 hours? So this one is giving 5 hours is our x value. So we're going to plug in 5 for x. So we're going to have 3 times 5 plus 5. It's going to give us 15 plus 5, which is 20. So there are 20 people in the park. So the kind of side note is match your values to know if it's x or px. So match your variables. That's the key thing. So the other one says if there are 26 people in the park, how long? So that's asking how many hours. So this one we're given our y and we have to find our x. So we're going to have 26 equals 3x plus 5. So we're going to subtract 5. You get 21 equals 3x. And then divide by 3 on both sides, and you get x equals 7. So they have been in the park 7 hours. Or the park has been open 7 hours. So you kind of have to do it both ways, and we're going to continue to keep doing this. Example 2, the height of a model rocket can be modeled by the function h of t equals negative 16t squared plus 64t plus 1, where h of t is the rocket's height. So h of t is the height, and t is the time in seconds. What is the model rocket's height after? So define our variables. So we know our x is time, which is seconds, and our y is the height. So if we can, A, B, and C all have seconds. So we're going to replace t. So we're going to take our equation, which is this long thing, and we're going to replace we have two t's, so we got to make sure we replace both of them. So we're going to have negative 16 times 1 squared plus 64 times 1 plus 1. So you could type this into the calculator exactly like this. So whenever you do this, I'm going to type it into the calculator. Negative 16 parentheses 1, close it, square the parentheses, plus 64 times 1, so put in parentheses, plus 1. And your answer is 49. So it'll be 49 feet in the air. So we're going to do that for the same for the next one. So we're going to plug in 2 for t. So we're going to negative 16 times 2 squared plus 64 times 2 plus 1. So I'm going to have negative 16 parentheses 2, square it, plus 64 parentheses 2 plus 1. This is going to give me 65. So 65 feet in the air. And the last one is 3. So we're going to do the exact same thing, but with 3. So negative 16, we change that to 3, plus 64 times 3, and then plus 1. So negative 16 parentheses 3 square, plus 64 parentheses 3, we don't have to square it, 1. You get 49 feet. So those are our 3 answers. So you're like, Mrs. Gilbert, why after 3 seconds did it go back down? That's because this rocket, this is called a quadratic because we have the exponent of 2. A quadratic graph will look something like this. It goes up and then it goes back down. So keep that in mind. Okay, next page. Do we have 2 more? Yeah. So it says each month, Mrs. Mariani orders packs of pencils at $2.50 each for the teachers that need them and pays a shipping fee of $1.50. This situation can be modeled by the function C of x equals 2.5x plus 1.5. C of x is your total, and x is the number of packs of pencils. So x equals packs of pencils. And y equals cost. Because remember, our C of x is the same as our y. So if she says in 1 month the total cost is $81.50, how many packs of pencils? So she gives us our y value. So that means we have to plug in our y to get our x. So we're going to have $81.50 equals 2.5x plus 1.5. And we're going to solve. So remember, we have to move our term without our variable first. So we're going to subtract 1.5. We're going to get 80 equals 2.5x. Then our last step is to divide by 2.5 on both sides to get x by itself. 80 divided by 2.5 would give you 32. So how many packs of pencils? 32 packs of pencils. Okay, let me know if you guys have any questions on that. let's go to our last example for the day. It says Mrs. Eiler's daughter, Alicia, called from Michigan to tell her that they had 28 inches of snow on the ground already. And it was snowing at a rate of 1.5 inches per hour. The total amount of snow, S of X, so the S of X is your total, X is your hours. Is modeled by the function f of X equals 28 plus 1.5X. Sorry, that's split up, you guys. So X equals hours, Y equals total snow. So the question, if it continues to snow for 12 more hours, how much snow will be on the ground? So 12 hours. This hours is our X value. So this is going to be our X. So we're going to plug in 12 for X. So we have our equation. So we're going to have 28 plus 1.5 times 12. Plug this into your calculator. You get 46. So she will have 46 inches of snow. Okay. Last problem. So this one's just a review. It says for f of x equals negative 5x plus 1, if f of x equals 16, so this is f of x, so this is this f of x, find x. So we're going to have 16 equals negative 5x plus 1. So remember, we want to move our constant first. And then we divide by negative 5. We're going to get x equals negative 3. Okay, one thing I want to hit on before we leave this, make sure for your word problems, I either want you to label your answer or I want you to write a sentence. A sentence would be preferred, but I kind of slacked and I did not write sentences on mine. So make sure you have to have some sort of label. If there's no label at all, I'm going to take off. So let me know if you guys have any questions on that, and you guys can get started on your homework.